Algebra 1, Algebra 1, Chapter 6, Section 6. So we're going to look at solving exponential functions. Just a couple more sections left to go in this chapter and we will have it completed. So we're actually going to find values of exponents. And to do that, let's start off with something like 3 to the x plus 5 power equals, let's go with 3 to the, oh, it really doesn't matter here. Let's go 8th power. Okay, and so we have two exponents that have the same base. We have the base of 3. So if those two numbers are exactly the same, you can brainstorm and say, well, if those numbers are the same, then their exponent values should be the same. And you are correct. So what we're going to do is we're going to take these two values and set them equal to each other. And then go back and use some old school algebra from way back when. And we're going to subtract 5 from each side. And that means x equals 3. Now, that kind of makes sense if we go back over and plug it in. That would be 3 to the 3 plus 5 equals 3 to the 8th. And when I add 3 plus 5, that gives me 3 to the 8th equals 3 to the 8th. And so that problem checks out. So all I do, as long as the bases are the same, is I take the exponents and I set them equal to each other. Now we'll get to some here in a little bit that have different bases and we'll convert them using the laws that we have already learned. But again, let's kind of stay basic on the next one, and then we will get into more intense type problems. What if I go with 8 equals 8 to the 2x minus 1? And so what you'll notice on the left one is there's not an exponent, but I've been asking you each time when we see these to go ahead and put the exponent that's in there, and that's actually 8 to the first power. So now, since those bases are the same, we're going to go ahead and just set the exponents equal to each other. And we're going to solve for x. So we're going to start on the right-hand side, and we're going to add 1 to both sides. That cancels over there. And so our final step is going to be dividing by 2. And so, in this case, x equals 1. So if I went back up there and I substituted that in, eight to the 2 times 1 minus 1. Whoops. That gets a little crazy on there. So that's going to be 8 to the first equals 8 to the 2 minus 1. Quite doing that. And so that's 8 to the first equals 8 to the first. So that checks. Again, you don't have to check it each time. I just want to show you that for just to make sure that we understand how to do that. Okay, so how about one where maybe the bases aren't the same? So let's go with 5 to the x power equals 125. Now, this is something that we probably could figure out. We could take 5 times 5 times 5 times 5, however many times it took to get to 125. But what I want to do is I want to rewrite this 125 as a base of 5. That way they have like bases. And they will get a little bit more intense here in a minute. So that's going to stay 5 to the x. And this one, if I took it to a power, 5 times 5 is 25. 25 times 5 is 125. So that's 5 to the third power. And so now that I have like bases, all I do is set the exponents equal to each other. Again, just starting off with a nice basic one. And that's x equals 3. Let's take it a step further on one that we might have to change both of them. So let's go 9 to the x minus 2 equals 27 to the x, excuse me, that's going to be x plus 2 equals 27 to the x power. So just like fractions, if 9 and 27 were the denominator, we would have to find something that's common between them. Now, we're not doing fraction multiples, we need to find exponents. So most of you will recognize that these are powers of 3, and 9 can be rewritten as 3 squared, and then I put the x plus 2 out there. 27 can be rewritten as 3 cubed, and then I put the x out there. So since my bases are the same now, I'm going to have my 2 times x plus 2, because that's what my exponent is, and that's going to equal 3 times x. So if I do distributive property over on the left-hand side, that's going to give me 2x plus 4 equals 3x. Now I want to take the smallest x to the biggest x, so to get a positive 2x to the other side, I'm going to subtract it. And that's going to leave me a value of x equals 4. So now I want to take one that's got a fraction in it, and let's go with 4 to the x plus 1 equals 1 over 64. 4 to the x plus 1 equals 1 over 64. Now, I know 64 is a power of 4. 4 times 4 is 16. 16 times 4 gives me 64. So I'm going to rewrite everything that I know right now. I'm going to leave this as 4 to the x plus 1. And over here, instead of having 1 over 64, I'm going to have 1 over 4 to the third power. Now, let's recall there was a section last week where we made something a fraction and we flipped it over to get the value, and that's when we had a negative exponent. We can do the same thing here, but now we're going backwards. It's on the bottom and it's positive, so we're going to flip it to the top and make it negative. So my next statement is going to be 4 to the x plus 1 power equals, I flip that 4 to the top and I make it a negative 3 power. Now I could put that over 1, but I don't need to in this case because anything over 1 is itself. And so now I have like bases, so I just take the exponents and set them equal to each other and solve. I'm going to subtract 1 from both sides and get a final x value of negative 4. That's just a little over 9 minutes. That is Chapter 6, Section 6, Solving Exponential Functions.